What's poppin', dogs? Mr. Allen here, about to start graphing some trig functions here. We got y equals sine of theta and y equals cosine of theta, our most basic trig graphs. And I'm going to go ahead and do some transformations at the end to show you guys what's going to happen as we start adding, subtracting, multiplying by particular numbers. It should be quite fun. All right, let's get it. Let's get after it. So our sine and cosine functions have a period of 2 pi. Okay, unless we start adding some multipliers in there and things like that, it starts as 2 pi, which is 1 revolution around your unit circle, right? So we'll say period is 2 pi. A lot of times we'll ask you to state what the period is, if there's a phase shift, amplitude, a whole bunch of stuff that you don't really know anything about right now, okay? But will come later, okay? Now for this one, we will talk amplitude here. So our amplitude is just how high up and how low it gets. Well, when we're talking about our values of sine and cosine around the unit circle, we're going to be talking about our quadrantal values, okay? So you're looking at either 0, 1, and -1. So how high up, 1, or how low, -1. From the x-axis in this case will be our amplitude. So our amplitude is going to be 1 for this one. You can see that when there's a coefficient in front of your trig function, then you'll have a different amplitude, all right? Cool. So let's scale this thing out. Let's think about our values on that unit circle, okay? So we've got ourselves 0. Then we have pi over 2. We've got pi, 3 pi over 2. And we have 2 pi. Okay, beautiful. And we can even go back the other way. Negative pi over 2. Negative pi. I'm not going to go much further than that, but usually we'll ask you just to graph one period, so really it would just be this section right here, all right? But they could say you can graph more than one period. It's up to whoever's writing the question on your test or worksheet, okay? Now, for our scaling of our y-axis here, I'm going to go by halves, so we'll make this guy 1, this 2. That way it's a little bit larger graph, okay? And then -2 right here. Lovely. All right, now let's go ahead and plot away. So what is sine of 0? Sine of 0 is 0. What about sine of pi over 2? Right, that's at the top of that unit circle. That value is +1. So I'll plot a point right there. Now, what's sine of pi? We're back down to 0 on our unit circle. And then if we got sine of 3 pi over 2, that's down here, right? That is -1 on my unit circle. Hopefully we're familiar with our unit circle, or at least our quadrantals for this. And then all the way back around that unit circle, we got 2 pi. Sine of 2 pi is 0. Beautiful. And I could continue back with these values here, but I'm just going to do one period for this one. So we're going to come up, curve back down. Got to kind of like find your next point so you can, make it look pretty. All right. And there we go. Beautiful. Our first graph right there. Sine of theta. Lovely. Excellent. Fantastic. Awesome. Okay. There we go. And what it will do is it would, repeat itself going back this way. It would repeat itself on and on and on forever. It's why we call them periodic functions, because they periodically repeat themselves. Man, I love when math makes sense. All right, let's go on to cosine of theta, shall we? We shall. The period is going to be the same thing. Period is 2 pi. It's how long it takes to repeat itself. Once we go around that unit circle, those values start repeating and repeating and repeating. The same is going to occur with the graph. Our amplitude, again, is just going to be 1. Okay, if we have a number multiplied out front here, that amplitude would change. Maybe we'll do one of those with our sine function after we get these basics down, okay? All right, now my scaling, I'll do the exact same thing. We got 1, 2, -1, -2. And here we're going to have pi over 2, pi, 3 pi over 2, and we got 2 pi. Cool. Now, we'll go ahead and graph, but we got to figure out some values here, right? So what is cosine of 0? Well, on my unit circle, cosine of 0 is +1. What about cosine of pi over 2? That's up top there, right? That is 0. And then we've got ourselves cosine of pi. Well, that's going to be -1. And then we have cosine of 3 pi over 2. We're back to 0. And cosine of 2 pi right up here. So we got to be careful when connecting the dots on this one, okay? Because it is going to come back down here to this point. So I want to make sure that my curve looks like that, like I know what I'm doing, right? I know where the graph's going next. So usually we'll have you do something like this, and then we'll come down, back up, and then again, I'm going to have to make sure that I'm turning to go back down because that's going to be my next point right there. So when we are graphing just one period, you want to make sure that it looks like this, like your arrows know they're going back down to the next point and not going up. All right, if you just go up like this, you are going to lose some points because you're saying the graph's going up this way when it's really coming back down. So be very careful with your cosine graphs when you're just graphing one period. With sine, it's just passing through, totally cool. With cosine, I see a lot of mistakes with that of like coming back up. Should not be doing that. It's coming back down here and coming back down there. All right, so those are our two parent functions, most basic sine and cosine graphs. But what if we were to do some crazy stuff, all right? I'm going to go with an orange marker here on my sine graph. What if I were to, say, put a 2 out front here, okay? So now what we have is y equals 2 sine of theta. What's that going to look like? Well, that's going to change my amplitude. So now my amplitude is going to be 2. So that's how high up and how far below the midline. In this case, the midline is our x-axis. How high above and below it goes, okay? And it just kind of like oscillates above and below. So now 0 is still going to be at 0. But since sine of pi over 2 is 1, and I'm multiplying that by 2, this point is now going to be way the heck up here at 2. And then sine of pi is 0. 0 times anything is 0. Sine of 3 pi over 2, that was negative 1. Well, negative 1 times 2 is negative 2. So now this point is way the heck down here. And then 2 pi is 0, so that point remains the same. So let's go ahead and connect these dots. We going way up, coming back down to pi. All right, excellent. So that'd be like a vertical stretch, right? If you're talking about transformations of other functions, it's a 2 that's multiplied outside the function. Outside is a vertical change, so it's a vertical transformation, a vertical stretch. There we go. Awesome. Fantastic. How about for cosine? Let's go ahead and let's add a number. How about that? I'm going to add 1. Well, what's that going to do? Well, if I'm going to add 1 to this graph, when I do cosine of 0, that was 1, plus 1 is 2. Oh, it's going to shift up here. If I had cosine of pi over 2, that was 0, plus 1 is 1. Then if we have cosine of pi, that was negative 1, plus 1 is 0. 3 pi over 2 is 0, plus 1, and then plus 1 here. We can start to see this like pattern that occurs. So now my new midline is right here that the function oscillates up and down from. Okay, that's a weird arrow. So I'm going to just connect my dots. We got to be careful on the first one here. And I always try to eye up where I'm going next so we can have a decent curvature to it. That was all right. It was decent. It was okay. Got a little funky right here. All right, there we go. So we just moved the whole graph up 1. There's other types of transformations that will occur here within our trig functions, but I'll save that for another video. Just wanted to give you a little preview of a couple things. We can have negatives where it's going to flip it. We can have numbers inside the function here that's going to change my period, how frequently these things repeat themselves, which can change some scaling. So a lot can happen here in our trig functions, but hopefully this introduction helps get you guys started and you continue watching some more dope videos hereafter. All right, see you later.